Hello everyone. In this video I'm going to be going through Hegarty task 178 and 179. The next video will go through Hegarty task 180 and 182, and then in the third video I will go through task 183 and 184. So this is a series of videos about equations, and I'm going to begin this video by doing a very brief algebra recap on things in algebra that aren't specifically to do with equations but are useful to try to remember before we do any of the maths here. So I would have gone through this again in class. I would have gone through it in bell tasks and starters and made sure that people were confident with all of this. I'm going to just address a few things here and then I will look at Hegarty task 178. So the first thing I want to recap is how to simplify really basic expressions. So if I have x plus x, or if I have 5x plus 3x, x is standing for a number, and in each of these it's going to be the same number, so you don't get to pick and choose what x is in any given position. So if we look at this first one, let me number them, number 1 and number 2. In number 1, if x is 6, then this is really 6 add 6. If x is 5, then it's 5 add 5. In the second one, 5x means 5 times whatever x is. And 3x means 3 times whatever x is. Because of BIDMAS, you would do the multiplications first, get those answers, and then add them up. So we do have to be aware of BIDMAS, and if that's something that you would appreciate a separate video on, I am happy to do that. Just send me an email. But for now though, let's just remind ourselves how to deal with these. So x plus x is of course written as 2x. If you were to substitute in some numbers, let's have a look. So maybe if I do x is 4, I would have 4 add 4. Now remember, this isn't going to be 24, it won't be written 2, 4, it's really 2 times whatever x is. So if x is 4, it's 2 times 4. And of course 4 add 4 is 8, but also 2 times 4 is also 8. So as soon as I actually put a value in for x, because to begin with x can be anything, as soon as I actually put a value in for x, adding up 2 copies of the same thing is the same as timesing that number by 2. Right? That's all that's really being said here. X add x is 2x. There you go. In this one here, if I have 5 x's and then another 3 x's, I have altogether 8 x's. And again, if I pick a number for x, let's pick x is 7. So let's pick x is 7. So here I have 5 times 7, and there's nothing special about x being 7. I'm just picking a random number. You can pick any number you want for x, as long as everywhere you see an x, that's the number you're using. So 5 times 7, add 3 times 7, and this is supposed to be equal to 8 times 7. So should we have a look? 5 times 7 is 35. 3 times 7 is 21. And 8 times 7 is 56, and as you can see, 35 add 21 is equal to 56. So just remember that a number in front of the x means that number times whatever x is. So it's just then comes down to doing a multiplication. Now another reminder that I want to give you before starting Hegarty task 178 is the difference between x terms and number terms in an expression. So if I take, for example, this expression, 3x add 2. A lot of people, when they see this, think it has something to do with the number 5. And I don't blame them for thinking that, because 3 add 2 is obviously 5. But this isn't just 3. This is 3x. This is an x term. So hopefully you can remember me talking about that sort of thing when we did algebra quite a while ago now. So this is an x term. And if you remember, terms in an expression are split up, are sort of separated by plus symbols and minus symbols. So here I've got two terms. I've got a 3x and I've got a 2 and I've got a plus in the middle. I could have a takeaway in the middle instead. It would be a different expression. I'd be taking away 2 instead of adding 2. So I've got an x term and I've got, when it's a number by itself, a number term. It's just a number by itself. So underneath I might write a more complicated example just to sort of illustrate this. If I had 5x add 7 take away 2x add 4, this is a different expression obviously to the one up here. It has 1, 2, 3, 4 terms. 2 of the terms are x terms and 2 of the terms are number terms. And this is an example of an expression that can actually be simplified. So that's another key word in algebra. How do we simplify this? Well, you pick a style of underlining for your different types of terms. So I'm going to go with a straight line for the x terms. Now, one of the key things that I taught was that you underline including the sign. And that sign is on the left. So I'm taking away 2x. This plus sign here doesn't belong to the 2x. It's nothing to do with it. It's that plus belongs to the 4. So you underline including the sign, and the sign is on the left. So those are my x terms underlined. I also need to underline my number terms. And I'm going to go with a zigzag underline. You can obviously pick whatever you want. And once I've done this, I can now simplify them. So I'm going to group the x terms together. So 5x take away 2x. That's still counting a number of x's. If I have 5 of them and I take away 2 of them, I'm left with 3 of them. So I would write equals 3x. I'm not done yet though, that was just the x terms done. Here I've got positive 7 and I'm adding 4 to it. So I'll go to positive 11, I'll be plussing 11. And as you can see, it simplifies down to an expression with 2 terms. I've got an x term and a number term. This cannot simplify anymore. This is nothing to do with the number 14, just like this was nothing to do with the number 5. The reason it has nothing to do, and I'll talk about this one again, the reason this one has nothing to do with the number 5 is because of BIDMAS. If x is 10, for example, remember at this stage where I've not got any equal signs going on, it's just an expression. I can pick anything I want for x. If x is 10, I do 3 times 10 first because of BIDMAS. Do the multiplication before I do the addition. 3 times 10 is 30, and then add 2 is 32. If x is 4, just pick random numbers for x here, I do 3 times 4 is 12, then I add 2 to get 14. So this plus 2 is actually happening right at the end after I've done the 3 times whatever x is. And that's really important that you realize that this is really, I do the 3 times the x, that's happening first. So in terms of what is happening to x in this expression, it gets timesed by 3 and you get an answer, and then you add 2 to it. And then you write down whatever your answer is. So again, if there's any questions about any of that, I can talk in more detail about expressions, but I would make a separate video about that. Just to sort of take what I was just saying and just extend it slightly. So last thing before I talk about task number 178 is just to really keep going with that theme of what has happened to x. So imagine I start with x. So remember, x can be anything. X could be 7, it could be 203, it could be 1,000,004, it could be anything. X at the moment, I'm just going to write it as x because it's just representing any number. And then if I wanted to So the sort of thing I have drawn in class before, but you may not remember, and perhaps I was due to do a bit more on it, was function machines. So don't worry about exactly what that means. This is just, if I want to start with a number and then add 3 to it, this is kind of how I'm going to draw it. So x, and then I'm going to add 3, and then what pops out? Well, if x was 5 and then it went into this, out would pop 8. If x was 17 and then went into this, out would pop 20. What pops out if I actually put in x? Some of you might think, well, it depends on what x is. And it's true, of course it depends on what x is. But algebra is all about doing maths, where I don't know what some of the numbers are, or where I'm maybe trying to work out what a missing number is. There is something that I can write here. I just write x plus 3. Start with x, add 3 to it, out pops x plus 3. If x was 17, what's 17 add 3? It's 20, what I said before. So I can actually make these more complicated. For example, I could ask, what happens if you do the x plus 3 and then times by 4, and then what pops out? So let's do an example with an easy number. So maybe if x is 2, it would go into here and out would pop 5. And then it would go into here and then out would pop 20. So the answer would be 20 if I started with 2. If x was 7, it would go into here and out would pop 10, and then it would go into here and out would pop 40. What do I write here though if I'm literally starting with x? See, there is something that I can write down. In fact, there are 2 options, because you're going to remember about brackets as well. So we've already seen what you write for this first bit. This was the example up here. You're going to write x plus 3. When that gets times by 4, you've kind of got 2 options. You're going to times the whole answer, so 4 lots of x plus 3. So remember, if you're going to times an expression, the entire thing needs to go into brackets, and then this is where we talk about expanding brackets. If I wanted to expand these brackets, if I wanted to ask, well, what is this here times by 4? Well, remember you do 4 times x, and you do 4 times 3, and you keep that symbol in the middle the same. So again, if there are any questions about this, I can talk about that in a separate video. I just want to highlight the difference though. What happens if you swap the order round? Because firstly adding 3 and then timesing by 4 gives us this. It gives us 4 lots of x plus 3. Or if I expand that out, I get 4x add 12. What happens if I swap those boxes round? What if I times by 4 and then add 3? Do I get something different, or do I get something the same? Let's have a look. X times 4. So there's literally a way in algebra of writing that down. That's 4x. So into the times 4 machine it goes, out pops 4x. 4x then gets put into the plus 3 machine. Now what happens when you add 3 to 4x? If you were listening really closely to the things we were talking about before, you'll know that's not to do with the number 7. It's going to just be written 4x add 3. So what's basically happened is out popped 4x and it's gone into that machine, and then it's popped out 4x add 3. There's no fancy way of writing this. That's just the answer. Okay, and what you can see is that these are actually different. In this one I times by 4 and then add 12. In this one I times by 4 and then add 3. So it's different. going to give you a different answer. So that kind of concludes that recap. I'm looking at about a 15-minute video already, so I'm actually going to save this as video number 1 and then do some actual videos like what I said before. So I should do it should now be 4 videos, so I'll make sure to clarify all of that. It's going to be 4 videos altogether, including this one. The next video will be on task 178 and 179. Video 3 will be on task 180 and 182, and video 4 will be on task 183 and 184. That recap took me a little bit longer than I expected, but I don't think it's a problem. I hope it was useful. If there are any questions about any of what you've seen, or you want any of it explained in any more detail, please just send me an email. But I'm going to sort of crack on with the equations tasks, just so I've got a series of 4 videos, and then we can go from there. Right, leave a like if this has been helpful. Send me an email if you need any help. I'll see you in the next video.